Welcome to another exciting lesson of math as we look at transversals and simplifying equations. As we look at this, we have deemed this lesson such review that we're going to cover two topics, transversals and simplifying equations. So, hang on tight. Here we go. Transversals. Transversals, of course, is when you have two lines that are parallel, such as this line here and this line here, and then they are intercepted by a third line like this. And because of that interception, there are unique features that we can find in the relationships between the angles. Right? Some of the relationships we see are alternating interior angles. We have alternating exterior angles. We have things like corresponding angles. Lots of different phrases that like to fit into this scheme here. And so what we want to do today is understand the relationships that exist between all these different angles and make sure that we can find any angle we want. Now, of course, all of this has to go back to one type of angle, and that type of angle is known as a supplementary angle. Because when a line comes together, such as A and B, angles A and B, we have this line right here. We know that that line is equal to 180 degrees. That means A plus B must be equal to 180 degrees. Just like the relationship between A and C is also going to be 180 degrees because of line T. Now, with all that being said, what we can see is that because of that relationship, we are able to kind of figure out any angle we want. And so to start, we're going to talk about this idea, right? It says we have this intersection so that the measure of angle A, that's this one right here, has been given the number 105 degrees. Find the measure of the rest of the angles. What? I know, it sounds ridiculous, but we just talked about the fact that lines equal 180 degrees. So if a line equals 180 degrees, that means this has to be 75, because 75 plus 105 equals 180, which means that this must also be 75, because 105 plus 75 is 180 degrees. And 75 plus this must be 105, because this relationship needs to be 105. Sorry, 180. I was talking too fast. But now how do we jump down and get to W and X? Well, the fact is that the relationship, because this line is parallel to this line, that means W is related to C in the same way that A and C are related. Together, they're going to equal 180 degrees. So that instantly makes W this. And very quickly then, we can start to fill in the rest of our angles. Right? And so we found the measure of all of our angles just by doing these calculations. Continuing on then. All right, here come the big names, right? Corresponding angles, alternating exterior angles, and alternating interior angles. As we saw from this picture, there's relationships between the angles, right? We have a 105, we have a 105, we have a 105, we have a 105. And so because of this, we have relationships due to their location. And as we look at transversals, we would talk about the fact that, I'm going to erase some stuff here just to make it clear, we would call in between the parallel lines, we would call that the interior, and outside, right, here and here, we're going to call the exterior. All right, and so we have those relationships. And so that's going to help us understand this part and this part, but what in the world does this mean? Corresponding. Corresponding works within this right here. And usually what we see is talk about the idea of, you could almost call it like the X factor here, because as angles get made, there's this kind of relationship between them, just like the opposite way there would be a relationship going this way. And so without even knowing the measure of the angle, I can right away say that angle 1 corresponds to angle 3. Just like I could say angle 2 corresponds with angle 4. They are the same measure. And I know they're the same measure because they share the same they share the same vertex and are going to work together like that. Now, alternate exterior angles. So now we're working with, right, this outside region here and then this outside region here. And as we look at that, because we're alternating, we've got to start in one spot. So let's start with angle 1. Angle 1, and now we want to alternate. We want to go to the other side of our line here. So if we hop to the other side and the other exterior. So if we hop to the other side, other exterior, we find ourselves next to angle 8. So angle 1 is an alternate exterior angle with 8. Right? Just like 2 and 7 would then also be alternate exterior angles. Finally, it says name 2 pair of alternate interior angles. So this is where we're going to just focus on this inside spot right here. That's our interior. And since I'm going to start with 3, angle 3 is one angle we want to alternate on the interior. So the opposite side of this line here, opposite side, opposite interior, 6 is going to be our angle that it corresponds with. So angle 3 corresponds with angle 6. So we have that relationship. All right, that is our extensive review of transversals. So let's talk about what else this lesson is all about. Sometimes you get different kinds of expressions, and as you look at these expressions, we have to understand what can we do to quickly solve this problem. And to quickly solve this problem, we're going to use different properties. Right? Just like we had the commutative property of addition and the associative property, these principles apply even though we don't have specific numbers. Even though we're dealing with variables, all those properties still work. So if I were going to simplify this problem, I would want to rearrange and group things. And so to start, I'm going to go ahead and use my commutative property and kind of rearrange the order of my problem so that everything that is similar or like terms is near each other. From there, then, I can use the associative property. Really, this associative property tells me is what am I going to do first. It's almost like an order of operation kind of thing. And so if I were to add in the associative property now, I would go like this, and I'd say, okay, I'm going to do this first, and then I'm going to do this, right? This idea just like that. Understanding that this is a positive x, and so we're still have a plus on the outside here. So it's 17 plus the positive x and the negative x, whatever that ends up being. Then my simplification is going to allow me to solve this problem. So 3x minus 1x, right? This is the hidden 1x, right? Gives me an answer of 2x. So now I have 2x plus 5 equals, right? 17 hasn't changed at all, but now I'm going to solve in here. A positive x minus an x gives me 0, right? If I have an x and I subtract an x, I have 0. And so in the end, I could very easily just say, well, forget about writing that 0. That's just a waste of my pencil at the moment. I've solved it. From here, then, we can continue to simplify just by balancing things out. I'm going to subtract 5 from both sides. Now that puts me at 2x equals 12. And then finally, I can divide by 2, and get x equals 6 for a final answer. And so by doing this, what I've done is I've applied all my different math applications to simplify this expression. And whether you think about it in breaking it down into that commutative property and associative property, whether you're thinking about those words, that's what you mentally have to go through to solve a problem like this. Now, as you continue working with this, it says we're going to simplify by removing the variable from one side of the equation and then solve. Okay. Right. So we're going to do a balancing act. With our balancing act, we're going to make sure that all the x's are on one side and all of our numbers then are on the other side. So in the end, we're going to slowly solve for x. Right. To do this, we're going to start by, it really doesn't matter where you start. It's just the fact that you're balancing again, right? So if I'm going to start, right, let's say I want the x on the left side. Somehow I want the x to be on this side of the equal sign. So in the end, I am going to have an expression that says x equals. Okay, so if that's the case, the first thing I'm going to want to do is remove the 17. Because it's a negative 17, I need to add 17. And so I'm going to add 17 to this side, and I'm going to group it together with its like term, in this case negative 5. So now I'm left with this equation of 5x equals 2x plus 12. So I have this expression. Now remember, the goal is to get the x to the left side and only have x on the left side. So in this case, now we're going to take our terms, right? I can take this whole term and I can move this whole term to the other side. So if I have a positive 2x, I'm going to have to subtract a 2x to get rid of it. So if I subtract 2x from the right side, then I must also subtract 2x from the left side. 2x minus 2x is going to cancel each other out. 5x minus 2x, right? X stays the same. 5 minus 2 gives me 3. And so now my new problem says 3x equals 12. Let's see if it'll let me move all this stuff up. Oh, it didn't take the line. Well, I'll erase the line, I guess. We have the expression, though, as it works. Finally, we can solve for x, and we can divide by 3, and we can say x equals 4. All right, I talked your ear off. It's your turn to work through this, right? 2 ideas. One of them is review. One of them is just a deeper application of things you've already learned. Let's get to it.